at this time. Okay, lather a bit, and then flip a couple, and then while when I'm done showing a couple of web links, the next thing that'll happen is I will unplug my laptop and you will plug yours in and get ready for the start of your talk. And then when I'm done blathering, and maybe we can go around the room quickly, and then the next thing, there's one up there, or you can use yours. But the two things that you need to be aware of is plug in your laptop and give your pitch for your idea of an English language fourth newsletter. I don't know about calling it Fourth Dimensions, but whatever you want to call it, it's your business, you know. Sure. But since you're doing it, you get to decide. And you can ignore the blathers of folks like me. Okay, so the important point I'd like to make right now is that we're starting the meeting. We're going to go back in time by about 1.5 minutes and start the meeting right on schedule. So those of you who are on the internet, I'm early. It's not clear. There was a bit that talked about some other thing, and then they say, oh, and you just go back in time and do this. And they said, no, we're just, travel is dangerous. All right, so I really liked Ting's talk this morning. I thought it was really great. Thank you, Ting. For those of you who are off mic right now, you can't hear all the vast panoply of applause. Ting mentioned two of the cores on course, the 8080 cores. This one is actually the interesting one for me, and I don't think Ting has seen it yet, because he said, oh, the other ones are kind of complex and stupid and didn't understand what they were talking about, and I agree with. And this is the only one that I found of interest to me, so I recommend it to you. And I think I sent out an email with links from the morning that, so with regard to new things, there's this article, Tech Republic. One of the things in this article is this watch band. The good news is you can charge your Apple Watch from your Apple Watch band. The bad news is it's, what, 250 bucks. But I guess if you've got an Apple Watch, you're not that concerned about money. And speaking of Tech Republic, they have this exciting article about photos of data storage from the 50s through the 80s. And the lead photo is this one of familiarity to some of us. So it's not a new thing so much as a thing. This is a new thing. Apparently the first motorcycle riding humanoid robot. Now, it's a non-trivial thing to do, but learn new things.
Why isn't it just the motorcycle?
Well, funny you should mention that. That was what I was going to talk about. I was brought back to the only autonomous motorcycle in the Great Challenge. The fourth, was it a fourth-based motorcycle? Anyway, Well, it lasted to very nearly the point where it went out to the desert to play, but I guess they forgot to connect something or turn something on, and it keeled over in the middle of the trials.
Forgot to basically turn on something, turn on the computer.
Yeah, well, but I believe it was fourth based, and anyway, this is that, but with the robot detachable from the actual motorcycle, apparently. So I guess they're the first of what it is, but all right. In my pattern here and theme of introducing these things that aren't new things in the new things section of the meeting, I recommend to you this exciting article, Classic Operating Systems You Can Run in the Browser. So later this afternoon, we're going to hear about another operating system that's not from the golden age, but I figured. So DOSBox on the browser or something. I think I sent a link out in the last month or so about a Windows of the bygone era that you could run on your browser. On that cheerful note, I'm going to unplug my laptop so James can come up and plug his in. And yes, let me run over to you so that the minions of the internet can hear you.
Welcome, Internet. You might be an engineer if you realize the glass is twice as big as it needs to be.
Right.
All right.
So the glass isn't half empty, the glass isn't half full, it's just too big.
All right. My word of the day is recalcitrant. A recalcitrant is one not observing Frisco's eviction of Tent City from division. And yes, thank you. Recalcitrant.
Well, it's hard to imagine resisting it when there are enforcers with live ammo.
Amazing. In San Francisco, they have love ammo if you're homeless. Lots of love. Well, speaking of revolution and why I have become such a patient revolutionary, I have guidance from such great minds as Marx, who was brilliant and observed, the paths of history, but he failed what could possibly go wrong? Things. And so when you think you've got a great idea, just remember, what could possibly go wrong?
All right. Anyone else? Rumors, gossip, new things, blather?
That I saw come across, I can't remember where. The OSH chip from timd.com,
Okay.
Wi-Fi and ARM at 1.8 volts.
OSH chip.
Version 1.0. And ARM M0, Cortex M0 with Bluetooth, low energy.
Okay.
1.8 volt to 3.6 volt.
It sounds interesting.
It does.
How many of you are on the email list? How many of you read the email list distributions? Okay, for those of you that didn't raise your hands, I recommend that you see George at the break and get on the email list so that you can find out all about the exciting stuff. George made reference to how you might be an engineer if article that Dave Jaffe linked to on the email list. So I recommend that to you. George is the keeper of the list, and he will get you going. And with that, I will hand this over to James, and he will make it radius, and then Washington can stop directly thereafter. Without further intervention.
Ah, finally. Okay. So Andreas and I were chatting, and we'd been both thinking along similar lines of how much we enjoy fourth dimensions as it exists in a giant archive of good stuff from back in the day, and I still read it sometimes over dinner. Wouldn't it be great if it still existed? If only the resources were available to do that. Now, obviously, the FIG doesn't exist as the FIG anymore, but some of us could get together, organize fourth dimensions. It's a big help that it's still going in Germany. So the German fourth dimensions is still publishing. Ulrich Hoffmann, he's an active fourth person, and I've chatted to Ulrich before, so it'd be possible to, and it's open source, so it'd be possible to take some of their stuff, like their documents, translate the articles and put them out in English as a sort of minimum thing. If you really wanted to live with Google translated German, we could edit them up a bit, and who knows, maybe people could even write articles for fourth dimensions. Just putting that out there as a possible dream. Yeah, put it on GitHub as a PDF, possibly as even a printed thing available via one of those print-on-demand services for people who like to have the paper version. As a show of hands, who would be interested in getting the paper version? Okay. Yeah, there'd be a PDF as well, but okay. Paper, okay. Okay. Who wouldn't download it? Wouldn't. Who would thinks it's a stupid idea and okay. I mean, the thing is about well, the thing is about when Fourth Dimensions was publishing, it sort of tapered off just as the web was starting up. Right, and Fourth Dimensions for a lot of fourth people was a way of getting their stuff out there, and it's the only way of like bringing it to the world. But now you can just obviously just make a web page somehow. But
it became impossible for Marlin to get articles.
Yeah. So the German one, I can't really read the articles, but I can look at the pictures, and they actually do seem to have real content. So there are people willing to contribute to it.
They have a real usership.
Right.
As opposed to us.
Okay.
I resemble that remark. It's not really here, it's called Do they have a real webcast? No. I mock them. Yes. we have a better readership.
So
We'd like to think we do.
who could imagine themselves contributing an article to a relaunched Fourth Dimension? Of any sort. Okay. All right. Okay. All right, King.
Contribute to meeting notes.
Okay.
You envision like every 2 months, that sort of thing?
Right. So the original Fourth Dimensions, I think, was quarterly, right? That's how.
I think it was twice. It was, and then it transitioned. It started off, it may have started off quarterly. For a while, it was every 2 months.
Correct. Volume 1, I think, was quarterly. I remember right. I have to look back.
Okay.
I've got them all.
Sending annual depending on how much you get, depending on how much content you get.
Well, that's why I would put it in GitHub, because then it's on demand.
Well, right.
And it print on demand.
Yeah.
Right. Eliminate all of publishing.
Yeah.
Eliminate it. The hard part you will have to do that is the editing that Marlon did. He would review the articles.
Right.
He would give guidance and getting people like us to write properly.
Oh,
is
okay.
Not a trivial task.
Well, as luck would have it, I'm married to a copy editor. So
You got one almost
just,
free.
she doesn't do anything. So
Oh, well,
she's, yeah. Okay. All right. Okay. All right.
Time for the next item.
yes.
The next item is Maker Faire. I forgot the exact date. It's in May. It's May 15th. So Monday is the last day to get an early bird ticket discount. So if you're planning on going, get your tickets online through the end of Monday. That's good. Are we going to skip the meeting? There will be no meeting that month because it is in commemoration of my wedding anniversary.
We're celebrating the event of my marriage by not coming to the SVFIG meeting that month. I make the excuse that Baker Fair is that month, and instead of going to the meeting, go to Baker Fair.
Yes.
Okay. Maker Faire is actually on the 20th through the 22nd. It's a Friday, Saturday, Sunday. So it's at the. It's just
Never was. It's not. Okay. I think you can probably start.
Right.
now that Kevin's not here.
When the cat's away. Okay. Hi, I'm James, and I've been working on a fourth on several hosts now for about maybe 18 months now, which is called Swap Fourth. And recently I got interested in automating the light switches in my house because I'm sick of turning them off and on. And I don't have any kids anymore, so now I can switch all the lights in my house off. So, and how do I do this? Of course, I need a fourth computer to do it. So this is what I'm going to be using, is one of these guys. I didn't bring one in today, but it's about the size of a postage stamp. What you've got there is there's a couple of modules that you can get. This is the sort of flat one. This is one with 8 pins on it. You give it power, and it's got a UART and 2 GPIOs, and there's a microcontroller on there. And that there on the right-hand side is the PCB antenna because it's got Wi-Fi built in. And shipped from China, you can get them for something like $2.30 in singles. That's shipped. So they are cheap. And it really is. You just give it 3.3 volts and you're in business. I mean, we're all familiar with microcontrollers that cost a few cents. But this is actually the full system running with Wi-Fi and everything. It's got, that's the CPU, the top chip. The other chip is the external flash. I'll get onto that. And there's a crystal and a handful of discretes. And they really are selling them. It's not a loss leader or anything. That is the actual price. It's around $2. Yeah. I don't think there's very much margin on that. But you can buy them in arbitrarily large quantities at that price. So there's no trick. This one is the non-FCC version. This one is slightly more expensive, the flat one with proper pads, and it's got more GPIOs. This is much more official. And this one, I think, is FCC approved. So I think it's like $3, $4. I mean, it's cheaper than a sandwich. I mean, why? It's so cheap it doesn't really matter. All right.
Where's the antenna for that one?
That's an external antenna one. So you'd bring your own antenna for that one. So these are all solder pads that go onto your board. So this is one is for using as a component, which is then soldered onto your board. No, that's just one of the pads. Right. All right. So right. I mean, they've cut every corner on there. Which brings me to my next point, that we're kind of used as computer engineers to looking at things like TING's 8080 and it being a heavily thought out system by very intense people. This is kind of assembled out of various bits and pieces at every level, and it's a bit of a mess and it doesn't work particularly well. My one at home has crashed my Wi-Fi network several times, for example. It crashes. Some of the instructions are a bit weird. The whole thing is this sort of hastily put together, just kind of works mess. So this is modern integration engineering, is that you've got to live with a certain lack of quality in the system and understand that not everything is going to be very great. At all sorts of levels, not just, we all used to like software being pretty bad. Everything here is going to be somewhat dodgy. This is the obligatory die photo. So there's the Wi-Fi section. There's some logic. But what's interesting about this particular architecture, and I think it was kind of quite clever, is it's just RAM-based. On the CPU, there's no flash, which is weird for a microcontroller because they're all about flash. And what they've got is I'll go back and say what the pieces are. So there's a Wi-Fi controller, there's a CPU. The CPU is, they might have got it for nothing. It's one that you get normally bundled with other stuff from a company that used to be called Tensilica. And from round here, and I think they got absorbed into, who's the design, the VLSI design people. And it's a CPU soft core that they licensed, and they've put one of those on the chip. And the rest of the stack is this software system, the SDK, which actually drives the Wi-Fi. That's where the Wi-Fi driver exists. And that's a big binary library that they won't show you because it's secret. And there's a manual for it where all of the APIs are described by one sentence. There's like an API called receive, and it tells you it receives bytes. Now I know. So you could literally take this 150-page manual and actually just put it on one page, because it's just like API. It's really just window dressing. There is a manual, the original manual is in Chinese, but apparently it's not that much better. So, well, right, and the Chinese description says receives the bytes. I mean, it's not. They give you some examples, and then you're on your own. So the way they actually sell it is not as something that you can particularly reprogram yourself. They sell it as something that connects over the UART and obeys the old 80 modem command set. So then you connect to the internet, and even that doesn't work particularly well, and it crashes, and nobody has had a lot of luck with it. But that's their intention. But they also let you override this initial bootstrap program and provide your own applications. And some people have got it doing stuff. There's a web server, for example, that somebody's got going, and it seems to stay up for sometimes. So, all right, so that's the situation with this thing. All right, so here's their clever thing. So they've got no flash on the die. So what they do is they have an external SPI flash. SPI is a serial, effectively a one-wire interface. And they have an instruction cache on the die. Well, yeah, okay, two, all right. So there's one wire each direction. So they talk to the SPI flash, which uses various wires, and they have a cache on the chip. So as you're executing code out of this SPI flash, which can be arbitrarily large, it's mapped into this cache space. And it's quite rare to see virtual memory on very small embedded CPUs. So this is how they get around the whole flash thing, because flash licenses are very expensive. And with this, they've turned it into just the board problem that you use an external SPI flash on the board. It also means that when you buy one, you're buying one of their chips with somebody else's random SPI flash, which is another source of bad news, because there's an arbitrary market in really lousy flash chips. Flash chips that have failed their manufacturing tests do not get put in the trash. They end up on this sort of gray market. And that's probably what you're buying when you're buying these very low-end ones, is flash chips that have failed their quality checks. So just beware. Okay, so I wanted to get my fourth running on it, and I've got swap fourth runs on various chips already. They're almost all of them 32-bit. One of them is 16, one is 64, but 32-bit is kind of the majority. Swap fourth is a native fourth. It doesn't use threading, and it's an ANS fourth. I use the ANS test suite to make sure that it is actually correct. Those are the sort of boundaries of what swap fourth is. How do I go about it? Well, there's a GNU toolchain you can just grab. It's just one make, and you're there. So that gives me an assembler and a linker. I can generate binaries with that, and they give you like hello world. So from that you can just add in an assembly file, and just hello world calls a piece of assembler, and so on and so on. It's just a small matter of implementing forth inside that assembly file. As far as development environment goes, there's a bootloader on the chip. You can toggle in a new program over the UART over the course of a few seconds. And the thing that talks that UART protocol and toggles in the program is this Python script that hackers have put together. And this is nice because swap forth also uses a sort of Python to handle its shell. So by merging these two things together, I have a combination bootloader and sort of Python shell to talk to the forth. So it's kind of Python makes great glue. It's particularly nice when you can just bash things together. So I have a single tool which bootloads it and then talks forth to it. Okay, so it's based on this extensor chip. It's, you know, when you buy a car these days and you look at the car manual, and it's like, the manual is like really thick and it talks about all the versions of the car that you didn't buy. That's what the extensor instruction set is like, because it's an IP core that they must have sold to lots of different people. So there's a zillion options on this core, which are if-deffed in the Verilog, presumably. So what you actually get is like just one instantiation of it, which then they have a manual which describes everything that it could possibly be. So a lot of instructions are optional, and you have to decide if you're going to get them. And the expressive, the people who've made the chip, don't tell you which one you've got. So you've got to kind of try and guess and do some experimenting. But, oh yeah, there's 2 Ps in support. So there's no stack on any of these chips. None of them have a stack. So this means that for forth, you know, you've got to make a decision about subroutine threading or indirect threading, or what you're going to do about that, which particular hardware stack you're going to exploit. It's no problem on this chip because there's no hardware stack. So everything is going to happen in software. It's going to be moving around stuff and simulating the stack. So here, for example, is how you load a literal. So I've renamed the registers here for clarity. So DSP is the data stack pointer. I'm going to add -4 to it. I'm going to move the data stack pointer down in memory. Store 32 is writing the top of stack into the new top of stack slot. And then I can finally, now I've made room in the top of stack entry, so now I can do this move R. Move R is what this chip does for handling immediates, and I'll be talking more about that later, but the immediate doesn't appear in the code stream. It appears at a PC relative offset. It's a bit like the way ARM does it, right, is you can specify this and you have some other piece of memory which is just that word lying around earlier. Okay, so stack work is not especially efficient, but it's no problem because it's a RISC and everything is 1 cycle per clock, so it all comes out in the wash. Other interesting thing is quite unusual, but it doesn't have any flag registers. So there's no carry flag, for example. Just don't get it. But this isn't just these guys. RISC-V, for example, doesn't have any flags either. It uses a scheme a lot like this one, so it's not completely crazy. What you do get is a combined jump, combined compare and jump instruction. So here's how you compile if. So if, obviously, you need to test the top of the stack is 0. That's the instruction that it does it. It's a branch not equal to 0 of a register. So you do that for the top of stack, and then the label, and that branches forwards if the top of stack is not 0. So it's all in one instruction. It's okay. That's what you get. Instructions on this particular CPU are either 24-bit or 16-bit. Some common instructions are 16-bit, and they're byte encoded. So instructions are actually quite compact. You can fit a lot in. Even a call is only 24 bits. So fourth code is obviously a lot of call, 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 and each of those is just 3 bytes each. So it's the same code density as good old 8080. Okay. All right, so next instruction, for example, this is how loop gets compiled, which is obviously going to add 1 to the loop counter. Loop counter is a register. And then there's the combined compare and branch instruction. Branch not equal to 0 on the loop counter, back to Y, back up to the top of the loop. So that's effectively a for loop is just 2 instructions. Sorry, an empty do loop is just 2 instructions. So pretty efficient, and so that'll run at like 36 megahertz, I think, with luck. Okay, so that's the sort of good about the CPU architecture. One of the problems is how they handle literals, which is all about, aimed at making things easy for a C compiler, which is not obviously a good fit for fourth. When you have a sequence like this, which is, as I said, moving the stack pointer down and then loading the top of stack from a PC relative location back in memory, in the C compiler, it just dumps all of its constants at the beginning of the function that it's compiling. And then, so you see a bunch of 32-bit constants, and then the code in that C function can actually just backwards reference them. This offset has to be negative. The constants have to actually go before the code in memory. Works fine for the compiler, it's no problem. But with fourth, right, we're generating this code instruction by instruction because there's a compiler running on the chip. We can't insert the constants before the code. We're kind of stuck. We've got to have things static as we're compiling the code. So what I have to make is a constant pool. So I allocate a sort of 1K area, which is my 256 constants, in early memory, and then all of the code that gets compiled later then has a backwards reference. So these that R value is actually goes up to 256 kilobytes. So there's a low memory, which is the constant pool, and then all the code after it can use that constant pool. At the point where we run out of constant pool space, make a new one and start over. So that's the sort of strategy. So this is what literal looks like. First, as a simple, this is a little optimization that actually I got the idea from Python. For small constants, you might as well just make subroutines. So I just bake in some subroutines for the small constants, and then you've got a subroutine to make 1, 2, 3, 4, 5. Just call them. If it's not one of these commonly found small integers, search through the current constant pool to see if it's already there. If it's not, add it in there. And then you can actually generate this code. You know what the value of R is because it's a backwards reference to the slot in the constant pool that you just found. If you've run out of constant pool space, then you have to insert an inline jump, make a new constant pool, and then proceed, because then you've got an empty constant pool to use. It's complicated. There's no real alternative. There's no way of inserting small constants into the code. So that's a huge pain compared with, for example, x86. x86, they're just inline always. Okay, well, a few wrinkles on the instruction set, but no deal breakers. Memory is a bit trickier. There's some other difficult things to cope with for their particular memory architecture. And of course, it's a flash-based system. So as swapforth is compiling its code, the dictionary is going into flash. So these linked lists is being constructed in flash. The code is being also put into flash. And they give you a couple of APIs to actually write to flash, and you can erase flash pages. The write granularity is 32-bit words, so it's pretty straightforward. You can just build up a few words in a buffer, which I call the burn buffer because it's going to get burned into flash, but not yet. So as I'm compiling, I'm writing into a RAM buffer for the current definition, and then as soon as I see semicolon, burns the burn buffer into flash, and we're done. So it takes a few milliseconds to do the burn, but that's not too bad. It doesn't really show up in interactive use. Okay, here's something that everybody who implements a forth that goes into flash has to deal with, is how do you do immediate? Because you've made your word definition, then somebody says immediate in the command stream, it's too late because it's gone into flash. Right? And there are various hackish ways of doing it, but fortunately this flash, you can rewrite it. So you can't flash, if you've never used it, is all ones, and then you write the zeros to it. So by default, flash is ones, and you can write a 0 to it. And you can actually rewrite a word and put more zeros in it. So it's possible. So all you have to do is, immediacy is indicated by a bit being 0. So all words have the bit set to 1 when they're created, and the immediate word just clears that bit. It's never going back to 1 until you erase it. So that's how immediate has to work. And this seems perfectly legal with that flash, and it works fine. Okay. How do you implement marker? Well, the other thing about flash is when you are erasing it, you have to erase on these giant 4K pages. So in forth, ANS forth marker, what it does is it says there's a place in the code where it adds a new word into the vocabulary which erases everything that comes after that word. And so what marker has to do is align the flash pointer to a 4K boundary so that it can be erased when it's time to turn back to that marker word. It's a bit fiddly, but no problem. Okay. And then things get really awkward. And you sit down and think, how am I going to get the forth to work on this machine? And sometimes you're led into quite difficult situations. And that's what happens with this one when it comes to strings. Everything works fine with my forth until I want to get strings going. And here's the problem with strings. That flash memory, also program memory, is sort of flash is this, the code exists in flash and then it's mapped into this cached memory window. But that memory area, which is program memory, which is the flash, is readable, but only in 32-bit increments. If you try to do a byte read from it, it's segfaults. It does not allow byte reads, doesn't allow misaligned reads. So, for example, when you're running through the dictionary, the word list, you've got to access its 32-bit fetches. That's fine for the dictionary search because it's like a custom piece of code. But what happens when you want to compile a string? you could for sure put the string in flash, but then it would not be accessible as bytes. CAT would crash. It's just not going to happen unless you built a version of CAT that did a little check to see if it's in the flash space, and that would be awful. So it's the same problem for C programs. Where do they put their strings? Because of course C strings have just the same semantics. Even if they're not writable, they're a const string, you're still allowed to use star to access them as bytes. Doesn't work in this particular memory space. You have to put them in the RAM. So string literal is tricky. What does it do? Well, it's not actually that tricky. All it does is finds out the current RAM pointer address, uses C comma to append it, and then calls literal to put what was here as a program constant. Right? So what you end up with is, if you say literal something, you end up with the string goes into RAM, and what gets compiled is a constant pointing to that address in RAM. Does the job. You've ended up, you've got a pointer on the stack which points to where that string is in RAM. This works fine. Until you reboot. Well, after a reboot, you've still got the same flash code, but it's pointing into RAM, and RAM's now 0 or worse. So leads to the last, the end of this, this story, is that the act of freezing the system so you can actually build a turnkey system, which of course is what I need because I'm building a light switch. I need to be able to, I don't want to compile it on the fly every time the light switch powers up. That's an option. What I really want to do is burn it into flash. And so what burn has to do, it has to take a copy of all of RAM, because it might have strings in it, and put it into the flash. And this is a sort of awkwardness that comes about because if only it was byte accessible in memory like this, this wouldn't be necessary. But unfortunately, because they made that choice and you can't access program memory as bytes, it leads to this huge awkwardness. Okay, so much for getting the forth going. The other part of the thing they give you is what they call their SDK, which is really just this giant full of secrets API, which is their driver for their Wi-Fi hardware. It doesn't really resemble any known networking API. It's not socket-based or anything. It's just whatever came to mind while they were writing it. I don't know. It's kind of troubling. But one aspect of it is that there is no main in your code. They set you up with an event loop, which you supply them with an event loop, which you pass to them as a function pointer. And then they call that event processing thing, which needs to return as soon as possible. You're engaged in this sort of multitasking conspiracy. And that event loop is only allowed to take a few milliseconds. Otherwise, you'll interfere with Wi-Fi. So don't mess it up. And don't, whatever you do, just sit in the event loop hanging, because after 6 seconds-ish, the watchdog timer will go off and it'll reset. So you have no choice. You have to return from this event loop, which is obviously more fuss on the forth side to make it look like this is we're part of this cooperative multitasking system. How do we implement key? This is all I've got going at the moment, by the way. I don't have any bindings for the Wi-Fi yet. So this is the only I/O. Well, I've got emit as well, but I've got key. Right, so what does key do? It takes the entire forth state, it puts it into a buffer, a secret place, and then it restores the stack, and it returns to the main loop. So the main loop is this piece of C, and it just called into forth. So then we return to it just as if we've done our work. Next step is, hopefully a character comes in on the UART, and then another piece of C pushes it onto an event queue, just as if we're an authentic C program written according to their guidelines. And then we've come around, we've done our duty, we've returned to the system, and then fourth restarts. It restores the fourth state, which sort of includes things like the data stack, but also much more fiddly is to restore the return stack. So that even if, I mean, key could have been called way down deep inside some other words. So you have to restore the return stack and then can restart fourth. So the top of there is freezing the fourth state. The bottom of there is restoring the fourth state. So if you like, if you're more comfortable with coroutine thinking, there's a coroutine which is the C world, and then there's another coroutine which is the fourth, which is running. And these two guys have effectively their own stacks. Okay, that's all I have on slides, but it's possible that okay. So I'll restart it. So this is my development system running. Okay, so I've just compiled the C and the assembler, and there's the link. And then it's actually built a couple of binary files there. You see, it's actually quite big with the SDK. Fourth is like 12K or something, and then their giant blob is like 180. And that's what you get. And then the Python script runs, and swap fourth works a bit like Jones fourth. It has a little bit of assembler to get the initial compiler going, and then the rest of it is just written in fourth. So it's sent down a whole bunch of fourth. So at this point, we actually have a working fourth. Let me just zoom that up a bit. And yeah, that works. I think I have, okay, this is everybody's favorite fractional approximation to pi. So it doesn't have software multiply or divide. So that was one of the things that had to happen was, it doesn't have hardware multiply or divide. So had to actually implement the multiply divide operators, which, and I think, yeah, look at that. So double precision. So so everything is actually working. So there's a full set of all the Ansforth words, and if I now run the this is going, what pound include is a sort of UART include thing. It's going to include all of these things that are in here, which is the ANS compliance suite. La la la. Pretty sure this is going to pass. All right, so now it's sending these thousands of lines. Oh, there you go. It's a genuine Ansforth passing all the tests. So it's all kind of set for plugging in the APIs now. But these APIs are also sort of cooperatively multitask. It's a bit like JavaScript, where it's you get a callback when something happens. So you never actually get completion on any task. You get a callback when it finishes. So it's okay to do that with this system. It's a bit like the system I had for key. Fourth has to suspend, and then when the callback comes, then it can resume. But how to actually expose that in fourth, I might just pretend they're all blocking calls. I mean,
So you put your strings in RAM and they stay there, but your return stack doesn't stay in RAM and you have to reconstruct it on the next callback?
No, the return stack is in RAM. All right. So yeah, so as soon as I suspend, I have to like save the return stack to stop C from destroying it. And then when fourth starts up again, have to restore the return stack to make it. But yes, you're right. except they don't tell you anything about stack usage. So I could make my own return stack, but they don't tell you anything about stack usage. So I don't know what their requirement is as far as interrupts are. Maybe their interrupt uses 3K on the stack. Yeah, let's not forget what happened to Toyota when they yeah.
Because what you're describing is sort of the early PC ports. They had to do the same thing. Is they had to save everything, but they just saved the pointers.
Right.
And go to OS. When it comes back to it, restore the pointers, and you're fine.
Right, right. So it's a lot like that, but without knowing how big their stack is, what I actually do is I just do a copy. I just copy that stack into a private space. But the C stack is unbounded. I mean, it usually is quite big. Particularly, I mean, they've got an interrupt service routine that might be several K, but the fourth return stack is tiny by comparison. So a 32 deep return stack is overkill. So it's relatively lightweight operation to preserve and then restore the return stack. It's no big deal.
Yeah, yeah, and that was typical also on the 68K systems.
Right.
Host.
Right. So it's running. If anybody wants to give it a try, just give me a shout and I'll send you a binary. But the hard part, I think, is getting the APIs hooked up and actually making some kind of sense. Right. Really, it'd be nice if the APIs allowed you to create something like a web server without it being hundreds of pages of code. I mean, obviously the ideal would be 1/4 screen would be a web server. I mean, how hard is it? You listen for connections, you send data back. But like I said, there's no sockets or anything like that, so you kind of got to fit in with their kind of weird SDK, which is quite difficult to actually turn into a coherent web application.
They tout this thing as having an integrated TCP/IP stack, though.
Yes, it is. It does have an integrated TCP/IP stack. That's
Described in Chinese.
right. You know, there's a callback that occurs when bytes are received. You know, right? So, yeah. But you know, whereas something like the sockets API for a TCP/IP stack is quite carefully thought out, and is still quite hard to use. This one is, yeah.
You may just have UDP.
Yeah, UDP. Just, yeah.
That's a different stack.
Right. So yeah, for my light switches, I might just use UDP. But if
Is this light switch a product for a company or a hobbyist thing or a?
it's just for me. I mean, it involves AC voltage. So this is.
You know, they actually sell.
I would not in.
Sell light switches.
Yeah, they also sell computers, but.
It's competitive coin, but it's not quite coin. Actually, maybe in the United States, but in Europe, it's still.
Yeah, you can buy a light bulb and inside it's got an integrated TCP/IP stack. Wait a minute.
Yes, it does.
Or it does.
Your usage.
It's even more bizarre. You can buy a battery for your smoke alarm.
Yes.
That has, I think I sent a link to the mill. It's got Wi-Fi, and it lasts for 5 years. And then at the end of the battery life, it sends you a message, I guess, on your smartphone that says your battery needs replacement. So it doesn't beep in the middle of the night, unless you've got the alarm on your cell phone.
Yeah, that battery actually came out at CES last year. As I saw that same thing, and it's pretty amazing because you don't have to go out and spend hundreds of dollars on some fancy smart thing when you can just have a battery and Wi-Fi.
And it's reasonably priced.
house is incinerated.
Yeah.
Ashes to ashes.
But
You are out of luck.
Have you measured power on this thing? Do you care?
so my power supply, it's not very energy efficient.
That's what I mean. I never look at Wi-Fi as being energy efficient.
Yeah,
That's
yeah,
why I'm tending toward the
so it uses a lot of juice. On the other hand, I've already got a Wi-Fi network, and this is going to go into light switches.
and you're on power.
Yeah, that's right. Of course. Yeah.
That's why
Right.
I figured you
Yeah.
didn't care.
Yeah.
So what kind of hardware are you looking at this little gizmo to?
So everybody gets their own sort of setup, and you can actually buy dev boards. Mine looks a lot. So just out of the
I think I linked to a dev board on the agenda page.
right. So I have a few of these. I mean, they're so cheap, you might as well buy 10. I mean, and then I have a few of those, and then I actually have just hooked up to the FTDI board and a power supply. And that's actually all you need to get going. Is you just got to torque on its UART pins, and as soon as you've plugged into that, you can actually just run the bootloader and flash it. Oh. So I've made a PCB with a socket for this and a power supply and a relay, and that's what runs my light switch. So right, so there's still going to be a switch, but that switch will no longer actually no longer work. It's a GPIO input into this, and then that will control the relay. What could possibly go wrong?
You know, let's leave that for the next. And you said the one on the left is not FCC approved?
That's right. This is the very cheap one.
What is the one on the right?
Oh, okay.
Because FCC requires the antenna.
Oh, okay, right. So I think Adafruit sells something which is, you can buy a variant with an FCC approval. So they're becoming, this first one is the one that they did at the very beginning, which has got them all the attention. And that's what really ignited the whole sort of hobbyist thing. So when you're using this, a lot of the documentation doesn't come from them. It comes from, like, you know, a wiki, because it's not their job to.
It has an antenna. It's very small and it's rectangular and it's tougher. If you hook anything up to it,
And it's very possible that they've got an FCC approval for that part. And as soon as you add an antenna, you're going to have to get approval again.
That's my question. This is Wi-Fi now. Are we talking 802.11?
Yeah.
Okay. All right.
Yeah.
something.
So is this something to do like with IoT?
That's what they're, yeah.
Because you know there are other, what's it, 802.15 or what, something.
Yeah, there's Zigbee, but I don't really want to administer a second network. I didn't want to administer any networks. Right. Yeah, I mean, obviously, once you set up Bluetooth, it never ever goes wrong. I mean, so, all right, thanks all.
Got juice?
Yes, good. Yes, we are juicy. us pray that this goes in. Won't be a putz. Make me look good. My God. My God. My God. Yes. Okay. As you probably have heard me talk over the years, I wanted to be able to get 4.3 system, a real-time operating system. I'm going to go towards DOS. Doing it, but the problem was my computer died. That was a long time ago. So, and G4 uses something has an interface to pthreads. Well, threads and real-time operating systems very similar. So I was thinking instead of that big jump to go from G4 right to a real-time operating system, why don't I take the little baby steps of going into pthreads? Well, that's what I've been doing, and I've been very successful at it. So, and the whole idea here is threading allows you to write code to do a specific job without having to juggle when to switch from one thread to another. That's what the RTOS is supposed to do. Pthread's all thing. It's not real time, but it does handle the the switching, and it allows you to create and control an old one of a thread. Nice thing, you set up, you can prioritize condition variables, read blocks. This is like if you have a queue, this will do, and you can synchronize multiple threads. Okay, and the nice thing about it is you don't have to worry about the switching. You just write your code and go. All right. G4 has the ability to interface to C libraries. In fact, you can also interface to G4. And that's how you basically, when you run a thread, what you're doing is you're running another instance of G4. And the nice thing about it is G4 has its own stacks. Now, pthreads memory area, and we'll talk more about that. G4 implements thread local storage, so you have different instances of your user area, your stacks, whatnot, and so you won't get in on the same memory. In this case, what I have is for a G4 thread, it's not like the way threads does, where you give it the entry point of a function to execute as a thread. Initialization that goes up front, and then the rest of the code gets spawned off as a thread. And I'll show you stuff like that. Now, you probably want to know about books. Okay, this multi-threaded programming guide, Sun Microsystems now, Oracle, there's a PDF you can look at, and it will go into excruciating detail on what threads, how pthreads works. There's also, if you guys are O'Reilly minded, there's pthreads programming. There's a extensive, it's an old book. And there are also many pthreads tutorials on the web. So you might want to take a look at that. These are all the different aspects of pthreads. You also, if you'll notice that you see like threads and thread attributes, and mutex is mutex attributes. Okay, this is all the things. In fact, I have ported all of these things to G4th. They somewhat function. I haven't extensively tested it, but they do execute. And like this, for pthread attributes, you can set your own stack area, how big it is, and a guard size. Now the guard size is using to make sure that your thread doesn't use too much stack space. Detach state, that's basically where you can start a thread and say, okay, this thing's gonna run forever, I'll just detach it, okay? And since now computers now have multiple CPUs, you can assign threads to run on specific CPU cores or multiple cores. You can set up scheduling priority, scheduling policy, meaning things like when a task and when it starts, it runs to completion, or you can have many tasks with the same priority and they'll run round robin. And then there's also being able to manage resource scope. Now mutexes, those are the things that allow you, they're like semaphores, but you can do process sharing. That means you can have a mutex that's only in the process that you're running, which could have multiple threads, or you can have it run all over the place, okay? And then there's a priority ceiling, then there's protocol, robust, and type. Well, you can look in the documentation to find out what all those things mean. There are also conditional variables, so that you could have a thread run until a condition is met and then exit. And then the clock is depending on what kind of clock you want to access in under, say, Linux. Okay. Read-write lock attribute. A read-write lock can be used for, say, managing, say, a database, where you can either have, you can come in and say, I want to read the database or I want to write to it. And this thing will manage the access. Okay. And then there's the barrier attribute, where a barrier is you can have several threads running same time, and you want to make sure that everybody synchronizes to the same point. Well, you can use a barrier to do that, and I also have a demo that actually shows that. Now, G4th has a C interface. There's a fourth source program file called libcc, and what that does is that's the guy that takes these small snippets of C code and compiles them. And one of the things that it uses to do that is something called libtool, which will compile and link and generate a shared object. And then using dynamic loading, which is very important if you want to do to use this aspect, it allows you to open up, say, a shared object or even a running program like G4th and extract out the entry point you want to use. And then you can just execute it just like a program. Now, this is an example of some C code. You'll notice that what we have here at the top is C library called pthread. And down here at the bottom, this is end. Okay. Here I have two functions. One of them returns the size of, in this case, a mutex type. I don't want to know, hard code that into Forth. I said, well, I'll let C return whatever that size is. I don't care what it is. Here we're using a function called thread mutex attribute init. And what you pass into it is a pointer to a mutex attribute. And basically what it does is, since this is a cell, like on the Forth stack, this is just translating it using coercion to turn it from a cell into a pointer to a pthread mutex attribute type. And then we'll call the C function pthread mutex attribute init, and then return whatever that information is. Then these guys down here, these C functions, these things relate what the fourth word is going to be called and what the C function is. And you can see here, that's what these guys here, along with what the stack effect is. And in this case, for pthread mutex attribute thread, mutex attribute size, there's nothing on the stack, and it will return n, which will be the size of the piece of memory. And here, same thing here, where you have the pthread mutex attribute initialization. What you do is you put a pointer, a variable, so to speak, on the stack, and what it does is it will return a status, which tells whether it was successful or not. And if it's successful, then obviously inside this address will be a completely configured mutex attribute. Now here is the fourth code. And right here is how I declare a pthread mutex attribute variable. I have a name, and then what's returned is a flag. Okay, and what it does is it puts the size of a mutex attribute on the stack and then calls buffer, which will then just allocate a piece of memory of this size. And here's the thing that actually creates this thing called mutex attribute. Now, in order to use it, you put the address of the mutex attribute and you call pthread mutex attribute init. On top of the stack will be a return status. In this case, I duplicate it and check to see if it equals 0. If it does, then this thing was created and I just dropped the flag. If I made a mistake, and we all do that, and this is not 0, then this message will come out, and this will take whatever that return value is and turn it into a string to say how you messed up, and then type it out in that. And that's basically how this stuff works. This is the C equivalent. Okay, as you can see, pthread mutex attribute type creates this thing called mutex attribute. You make the function call by passing of mutex attribute to pthread mutex attribute init. If it equals 0, then I just print it. It says yes, I created. Else, I can print an error message and translate the error number that caused the problem. And I have examples that show I can have multiple threads. I can do thread synchronization using barriers, and I can manage output of those threads using a mutex. And I think I'll do that right now. Is this the guy? Yes, this is the guy. Actually, let's do this. Okay. This is under Linux. I built my own local version of G4th, and I'm passing a program called barrier test. And barrier test looks like this. No, that's a better thread, so idiot. There we go. Okay, one of the things that I have to do here initially, you can see here, is I have to include this thing called better pthreads. That's the name of the force source that I created that encapsulates all the pthread calls in Forth. You can also see here I have variable declarations. Threads can also return values if you want, okay? and in this case, I have 4 threads that are running. Here, this pthread variable is a piece of memory that pthreads uses to manage a thread. And then you can see down below it is I have this thing called pthread mutex variable, where I'm just creating a mutex. The next thing we have here is I obviously am creating a mutex. And notice that there are 2 values being pushed onto the stack. That's the address of the mutex, and notice this 0. Like I said before, you can change, if you want, you can modify the attributes of a mutex. But in this case, I don't care, I just want a mutex. And you can see it calls pthread mutex init. That will return a status, and in this case, I just want to make sure that if everything's good, then it'll print out created, or you screwed up somehow. Same thing with a barrier. I have another thing called pthread barrier variable, so I can create a barrier object. And obviously it's the same thing. Now with pthread barrier init, you have to pass the address of the barrier variable. And if you want any barrier attributes, in this case, I'm passing 0, so I don't want to change any of them. And the number of threads you want to synchronize. And this pthread barrier init will initialize your barrier variable, and it does the same thing that I did for the mutex on checking for errors. This code here, I will be able to run 4 instances of this code, and you will notice that up here we have to do initialization, where I have to pass in how big my stacks are. Okay, and then these are words that create a thread, and this pass, you will notice that in this case for this test thread, I have 2 parameters, a return variable and an ID that gives it like what thread number it is. And you notice that I have to put a count in there. This 4th word requires to copy from one stack, 1/4 stack to another, okay? And then here, I put an iteration number here. This is 0. Then I've got this big loop, and what it does is it attempts to lock a mutex. Now remember, because I got 4 of these guys running at a time, I want to make sure that only one of them runs at a time. And you can see get the lock without, doing something stupid. And what it does is it will print out a test instance number of the test, and what it'll also do is print the iteration count. Then here, what it does is it'll wait for a second and then unlock the thread. And the same kind of thing, just to make sure everything is going fine. Then, if everything, you increment iteration count, and you wait to see if it equals 4. And if it equals 4, you exit. But if you look here, all this is going to do is just come down here and execute pause, which is like a wait, and do that 100 times. Now, and we print out a message to say what our what our instance number is, what our iteration count is, and we're saying we're exiting. And right here is where, for all the threads, this is where they wait. Okay, so we can synchronize. And again, I put all this stuff in here, these messages, just to make sure everything's working fine. Then down here, we print out a message that says thread, and then the instance number, and then where we're saying this thread instance is ending. And then down here, what we're doing is we're taking 0 and turning it in one of those return variables. And then we do the thread exit, and then this thread actually just dies. Here, this is showing the parameters that are being pushed onto the stack to run test thread. And you can see I have 4 instances of this. And so you can see here that I have a return value, an instance number, and because pthreads that I have 2 parameters to copy onto the stack, and it does that. And then this thread variable is what gets used into creating a new thread. So you can see this guy will run, and this will actually show it. And what's nice about that, after all these guys run, what you can do is you can wait for each one of these threads to finish. And that's what this pthread join does. So what you do is you pass it the thread variable, and then just say, you know, join. And what it does is it waits for that thread to finish. And you can see I've got all 4 of them here. And then after I've gotten all the threads, you know, have finished, then I go about destroying the pthread barrier variable and the mutex, and then I'm done. Now, let's execute this guy. You can see these guys are all running. You can see this test thread is running as an independent thread. And you notice that they're all not in the same order. Okay. So you can see each one of these guys. In this case, you can see that the second instance of the thread got executed. And you can see it goes thread instance 2, 3, 4, then 1. Actually, here it is. 1, oh no, 1, 2, 3, 4, sorry. So you can see that each iteration got run from 0 to 3, and then each one of these guys exited. And you can see that each one of these barrier, so they're all now waiting at the same point in the code, and then exit. And that's what this pthread join is saying. And then you can see I've destroyed the barrier, and I've destroyed the mutex. That is how, that's the kind of an example of what I can do. Okay. All right. Future work. I'd like to be able to show some of the more obscure aspects of pthreads and what you can do with it. Also, I'd like to be able to create inter-process communication objects, such as a mailbox, a queue, event, things like that, that are implemented in using pthreads. I've abandoned trying to port to ECOS because one of the things I found out with ECOS is, although it does support dynamic loading, it doesn't support NFS, network, file system. I'm switching now to RTEMS, which does support both. And the reason why is when this G-Forth code runs, it has the C code in it, it calls libtool. Well, I'm running natively under x86. Well, that's all fine and dandy, but wouldn't it be nice if I could do the same thing, say running under ARM or PowerPC or some other one, and be able to have a libtool version that runs under that architecture? Well, I don't want to have this to bring over and GC, which is huge, into my development system. If all I have to do is just do an NFS mount of where this stuff exists on my development system, and then when it runs, all it does is say, oh, well, I go look. It's just, it'd be like, you understand NFS. It's just like you have the this portion running in your local system when in fact it's resident on another computer. And the nice thing about this is you don't have to have actual networking. You can use something called QEMU, which has a network interface to it. It's just that it's like using LO in the system. So you can develop like that using QEMU. Say you have an x86 64 machine, but you say, well, I want to run ARM. Well, QEMU will let you run ARM. And if your operating system that you're running under this virtualization supports NFS, well, then it can actually go in and mount all your stuff, which is actually resident on your x86 machine, and then have LiveTool do its business, and you can develop to your heart's content. And then the next thing you do is, if I'm not mistaken, something called Save System. Am I right on that, guys? Yeah, what it does is you can take your develop, just make an executable for you, which means you can then load it onto your actual target and say, run. So, any questions on this stuff? Yeah.
Does ECOS support the Virtuo file system for like shared folders and everything?
Not the free one. Yeah, see, ECOS comes in two flavors. There's the free one that everyone can access, and then there's the one from Ecocentric. And it has the ability to do a lot more stuff. Okay, they claim they have NFS, but I kind of doubt it. But you have to pay an arm and a leg for the licensing. That's the reason why I'm going to RTEMS, so that it has what I need. So that, and also the nice thing about it is, although RTEMS currently doesn't support USB, one of the things I want to do is I want to be able to create my own USB hub, so to speak, meaning not only can I plug into a root hub system like on a PC and have this thing do its stuff, I want to be able to use OTG and be able to plug in whatever, a thumb drive, a phone, and I can have this hub do whatever. Say, if you remember many years ago, Ting did a DSP. Remember that? You did a DSP thing. I forgot what the process is. This was when we were in the other building over that doesn't exist anymore. So that you can actually, make your own DSP. A spectrum analyzer if you want, or a voltmeter, whatever your heart's content. But it can be a USB device, so that you can plug it in to your PC and do whatever you need it to do. And there are USB stacks that do support not only devices, but it also supports hosts, and it does OTG. And that's really nice. I'd like to be able to do stuff like that. So, like I said, any other questions? I still have a lot more work to do on this stuff, this pthreads. I've been, like I said, working on it part-time, as we all do our fourth work. I don't have the luxury of being like Ting, and I can say to work. Yeah. But the nice thing about this is using pthreads, now I've got experience using the live CC fourth, dynamic loading, things like that. So now once I've got that working, now I can then say, okay, let me see, instead of running under Linux, see if I can run under RTEMS, see if I can get it working that way. And then once I get the virtual RTEMS running, Let's say, okay, can I get this running to actual hardware and see if it does its thing. Okay? Thank you. Excuse me?
2:30.
2:30.
That was remarkable. Thank you.
You're quite welcome.
Take a short.
Okay. I'm going to need your help again. Oh, by the way, guys, I spent 5 days in the hospital. I had a bad case of septicemia. And the horse pills they gave me, one of them, the problem that they cause is dizziness. I have a bad case of vertigo. So it's like I'm going, oh God, when is this sea voyage going to be over? Thank you. Thank you. Let's see, where's the business end? Yes, thank you.
So John,
Yeah.
NFS started out, I think it was a fairly simple UDP protocol. I don't know what
Yes.
it's grown into today, but I think I can remember seeing like hacker clients used for scanning the internet that were just not that big a C code to do NFS.
Right. But the thing is, I'm not that interested in developing something like that. I want to say, oh, this RTOS has that capability. Fine, I'll use it. So all I have to do is build a native live tool system. Okay. So I can have a build, say, for ARM or MIPS or whatever processor. So that then when I have a virtual system, say, running an ARM, then I can tell, say, RTEMS, okay, I want you to do an NFS mount of this system, which will point to that native live tool system. So that when it says, when you in the code, when it says run live tool, it says, oh, there's where live tool is. Okay, oh, there's where GCC is. Oh, that's where the linker is. Oh, and it's native code. This is this isn't like a cross compiler, although I will be using a cross compiler to build a native compiler. That's the idea.
Okay.
And the nice thing about being able to build all this stuff, say like I want basically it's a root hub, is it's written in Forth. So if you dump it, you're going to say, well, this doesn't look like C code. This doesn't look like anything I'm familiar with. People will, God damn it, excuse my French. Didn't mean to say that. It'll be more obscure.
Yeah, did you say it on the internet? The red light's on.
Yes, I did. Please forgive me. Mea culpa. Mea culpa. So.
do that. And then Microsoft comes out, oh no, we're behind that.
Do you have to do anything, Dennis?
Do I have to do anything? You have to just turn it on and hook it to yourself.
Yeah, you have to clip this to your collar or your shirt. Because nobody will be able to hear what you say.
Yeah, okay.
All right, start down, stand in front of the screen.
Stand in front of the screen. Okay.
Listen up.
I'm Henry Strickland. About a week ago, I decided to write a fourth, and it's called Ninth Fourth so far. There is a web page where I've thrown up my sources and stuff so far, and there's also a GitHub. But if you start at wiki.yak.net/1092, yak.net/1092, you'll find these. I brought a few printouts of the handouts. I'll put it on the board, yeah. It's for Motorola 6809 for OS 9 operating system by Microware. And I've got it running on a emulator that I've spent a few more weeks on hacking up the I/O emulation to make it do the OS 9 copy that I've got. So what's interesting about the fourth, it's a indirect threaded, but if it's going to go into a compiled OS 9 module, it's read-only and it's relocatable. So all the pointers have to be relative. And even in my read-write RAM area, I want to make them relative so I can pickle that and reload it back later, which might be at a different place in memory. All right.
So you got to hang out at church and see, grab a copy. We'll put the link on the flat.
Can you unclip this without making too much noise on the internet?
Over there.
Okay.
So, should this just turn on or something? The projector?
Putting something out, it would be up on the
Yes,
screen.
it will get there eventually.
Yeah,
There it is.
There
It's
it's
starting.
it's starting.
Something's happening. It's syncing
It's
up.
thinking. Oh, it gets there occasionally.
128 by 800.5 pixels. That's an odd number. What's a half a pixel? Is it like a little bit pregnant?
I think they do have pickles these days.
Yeah, there's a whole bunch of anti-aliasing
Yes.
algorithms that
Some
percolate
pixel
pixels.
alignment. Yeah.
It's so hard.
Is this working?
Yeah,
Not yet.
you may have to drop your resolution.
Yeah, I'll try that.
Not drop it automatically. Sun out. Keeps on trying.
There's only one resolution option here for both of them. It's odd. Did it all the way? Yeah. I could try with another window manager. That might work. I tried this morning on my TV. Just a moment. Huh. Are you recording now?
It's still recording, yes.
Oh.
And playing over the interweb.
Everybody is sitting at the edge of their seats, waiting for you to get it working. Not to put any pressure on you.
No.
This is new. This is normal for a newbie. Oh, you had something there for a moment.
I just checked. Oh no. I could plug it in if that helps.
Just a moment.
The rabbit used to say.
And then you go to sleep. Oh, what is it? Where did you work? Unfortunately, they said lettuces make you sleepy. It's like, oh, you idiots! Don't you want them to
There it is. That's looking like that, a loose connection.
Oh, you just showing slides? You got stuff.
They're online, so I could, if I could borrow someone else's computer, that would also work.
Let's try that.
And you're trying to do HDMI.
Yeah.
Yeah.
I also have mini display port. That works.
You want to try with mini display port RGB?
Would you rather just show it off the web, or would you rather
Which way you
fiddle
want
around with that?
I could just show it from a web browser.
that? May be
Search for fourth
because we know
Soon.
these work.
slides.com 4thfs. Just in Google. Space 4thfs.
Okay.
Okay.
It's up on the screen now.
Just so you don't like have my Gmail account logged in. Everyone knows my email now. It's on private browsing, so. Everyone can verify for me.
Marking tells you it's a private browser.
Oh, I just opened a private window, so he. There we go. Oops.
Oh, you decide how long you want to speak and stop it from and the meeting on schedule.
Okay, you got 2 minutes left.
Okay.
Oh, I know. This isn't fourth day. Yes, it's a new.
So there are some things that have been bothering me about modern fourth. Namely that the compose, run, debug cycle is, well, when I came to fourth first, I was promised a short compose, run, debug cycle. So I could just edit code on the older fourth systems, you would edit code directly on the system with a block editor or something like that. And this worked pretty well. However, on newer fourth systems, nowadays I do like to have a high-powered editor with all the plugins and extra features added, and I'm comfortable with that. So yeah, there are a lot of plugins here. I don't use quite this many, but I do like a high-powered editor. And although I do have a minimalist streak, which is why I also like block editors, I don't actually end up using them. Although Sam Falvo did write a nice one, Vibe, which is very Vim-like. And but on the other hand, now I'm also spending a lot of time uploading code. As I use AM4th a lot by Matthias Trout, and I spend a lot of time waiting for code to upload to the microcontroller for a long. It takes almost more. I would say it takes more time than compiling a C program and flashing it to the microcontroller. Unfortunately, which is not what was advertised on the tin. So I do. So while I have the block editor, and it's also difficult with a block editor to share code with others, as we know from ColorForth. It can be difficult to share source code with others on the internet if you're isolated in your own invented all here system. So I thought, why not? I would like a way to mount the address spaces of the microcontroller onto my laptop, which is over there now, such that I can edit the code in my high-powered editor without uploading the entire source code and all its dependencies each time I make a change. And so I created a tethered fourth file system. My first thoughts were to create a fuse file system that sends cfetch and cstore words to read and write to the microcontroller. I moved away from that approach because there's just too much overhead with the cfetch and cstore for each byte. It pollutes the history and all that, and it's not the simplest fuse. It is Unix. It's not the simplest anymore, as we were discussing at lunch. And I may want to mount a file system on another microcontroller too at some point. So I may want to mount not only a file system, mount the microcontroller's address spaces onto my laptop, but also mount the laptop file tree onto a microcontroller, potentially. So I was looking towards Plan 9, also known as Plan 9, because it says no to extra ornamentation and bloat and complexity that accrued with Unix. And it's also it was designed to be as if Unix were invented in the time of networked computers, distributed networks, or the internet. And so this is a screenshot of Plan 9, and actually the 9P file system protocol is, well, in Plan 9 everything is a file, and it's actually meant for real this time, unlike with Unix, where it's sort of somewhat true, but not always, and it's something they say, but it's not really true. But in Plan 9 it's more true, but also still not always true, but because they do have some other primitives. So I looked at the Plan 9 at the 9P file system protocol, which was written for Plan 9, not from outer space. Plan 9 from Bell Labs, and So this 9P protocol is very simple, much simpler than Fuse. It's just these commands right here. Basically, you need to operate it with a file system. You have attach, which attaches the version. You start with version, which negotiates the size of maximum message size of one of these commands. Then you go to it like attach, for instance, to attach the file system. And then you would probably stat would be next. You may use stat to get information about a file or a directory, and so on and so forth. But I didn't go with the case end case for my to determine which command to respond to. I just I compiled a list of a lookup table of execution tokens, and then just took the command byte from the received message, and then added 1 to it to get or just looked it up in here, and then to execute the response. So instead of using a case end case, it's more event driven and few. Then I've also been looking at how to factor and refactor and slice and dice the code, and that's what has been consuming most of my time now. Just to not have it be full of conditionals and so on and stack juggling. I just wanted to have it something very simple and lightweight. It's written for ME Crisp Stellaris 4th by Matthias Koch, or Koch. It depends on, by the way, it depends on hardware. It requires hardware flow control, because we can't, in case if you plan to use it on another system, you need hardware flow control, because I can only send 9P commands over TX and RX. I can't send software flow control things, and I did not do it such that I time it. I did it such that I would build the response as I receive the message that arrives. As I receive the request, I build the response, rather than buffering the request message, the so-called T message. I parse earlier rather than later or offline. I parse online. I parse as soon as possible and process it into data structures as soon as possible, because it seems to save a lot of complexity. And then I was thinking, like, I was using words named like T message, R message instead of this, and I thought, well, we have so many words in the English language, why not use them instead of acronyms for everything? So I just I sort of tried to exploit the subtle differences between words. Like, instead of having like a T message here, I do comprehend, because I named it comprehend because I receive the message and I organize it into data structures, such as the R message, which will be the response, and then I speak it by, this is just a alias to type, and it just then it responds, and then that's converse, and then that is a iteration of a conversation. So instead of using acronyms, I just try to look at the small differences between English words, and then, because we have a lot of factors in fourth, our words are smaller, we have more of them. Our definitions are shorter, but we have more of them. So sometimes I'm grasping to find, I'm struggling to find words to describe each slightly different word. And so I just thought, why not just use the dictionary or the thesaurus or so. Yeah.
Especially
Mhm. Yeah. Yeah. So as Sam Falvo was saying, it's best to describe what a word is, what the result of a word is, not what it's doing per se. So I thought like I described the response. I thought at first I was describing the T message with my definition of walk, which is one of the 9P commands. Then I thought, well, I should describe the R message. And then I have this, which corresponds to this. I have that, which corresponds, this is the number of, so a quid is basically a way to identify a file in 9P. It contains the version, the path, which is just a number to identify, and it also contains the type of file, like whether it's a directory, whether it's a regular file, or whether it's an append-only file or an exclusive use file. And then I have, this is the number of them, and this is the list of quids inlined. And these words, they build that into the R message, which is buffered. And then rather than, yeah, so I didn't describe the T message there, but I do describe it within these, because that's something that comes before. So it makes more sense to describe it within these two factors of the R message. You describe the factors of the T message. Missing slide. Oh. So something I learned from this project was that I should not juggle my arguments into the position at the beginning of a word, because that's sort of, I found that that's a sign that my program is being, my words or my software is too general. So rather than doing that, I would place the arguments where they belong in the first place, embed them within the word, so that I don't try to make it so general that it fits in any situation, but then it fits in different places, but then I have to juggle these into position where there may be a mismatch. Seems to be the source of a lot of stack juggling. But so yeah, so I try to embrace the edit time, side of computing. So because I need to remember that I am the highest level of abstraction on my computer, so I need to embrace that as well, not just try to automate everything because we have an editor, and that is a way to it will be simpler if we just have programs that are simple enough to hold in your head and change later, rather than try to add hooks for future functionality that we may not even know about yet. So there are some improvements I would like to make in the future, or some of them I've already started making, but others I'm still thinking through. So with 4thFS, when we mount the file system over UART or so, we have a block, like a file that we can add source code into and stuff. But that means we're occupying the serial port. So I think it would be good to have export a append-only file for the prompt as well. So then you can have both sort of multiplexed in a way. And then something I found is that I get these swap files, these like temporary files from Vim, and I think I should have some like overlay FS layer to catch those swap files, so I don't write them to the microcontroller, because that would be not what I want. And then Something I wanted to do was save time and flash lifetime as well by only writing what has changed. That might require some overlay FS layer as well, which I'm not sure whether that's more complicated than I would like, but it would save flash lifetime and my time as well. And did I skip this slide? So then it would also be nice to have device files for the sensors and actuators as well, because you can consider those. You can rebind, fetch and store to write to those as well, not just to like a SPI flash or the internal flash. You could just rebind it to write to any sort of peripheral, because in Plan 9 you can actually mount. Remember that you can mount a sound card over the internet as a networked file. Because it's a networked file system, you can mount device files over the web, over the internet, not the web. And you could another thing you could do is mount the network card of your router to sort of create a VPN type thing. And so I may also want to defer key and emit so that I could run 4th over any sort of transport media, like a radio or like a low-raw radio or anything really that can do key and emit. That would be interesting for remote sensing networks. And then in that case, I may want to have a 9P client as well, as I mentioned before, so I can mount a file system from one sensor node onto another node or onto a Linux laptop or anything that can run 9P, which is not difficult because 9P is so simple as far as Unix-like things go. And then now maybe I might want to have it in a turnkey so that it would start up at boot. And if I have the append-only prompt file and the and everything else, then there's no reason not to put it in a turnkey, I would think. So it starts up on power on. And then, so it's available here. It's not done yet, and this is an older version of it, but I'll upload a new version as soon as, like, within the next month, the newer version. And it's available there in a repository. So my current progress, I'm just laying down the server right now, and I'm also just refactoring it, as I just trying to have as Thinking Forth said, the whole-brained thinking. Think of the whole when you factor. Don't try to overfit it into rigid data structures, which is what I was doing in the beginning. I thought, well, maybe I should really use structs. And then I thought, well, could I have a struct that starts at not 0, but it starts at a buffer address, and then use something like maybe key to receive to populate the struct instead of storing offsets, but that turned out to be too rigid. And I think it's best to write it as plainly as possible first, and then pull out the factors like you do in algebra, and then it will fit the problem rather than trying to fit it to data structures that were designed beforehand. So do you have any questions, comments, or worldviews? Yeah.
Someplace else.
Yeah.
It's kind of like what I'm talking about. What I want to do is have NFS where I can mount this stuff where I can have my light tools in GCC, but I can also have my source files.
Yeah.
So that I can actually edit them on my target, my O target.
Yep.
And then everything, all that, and knowing that it's in a safe place in case my target
Well, it will be on your target, but you can back it up. But
Exactly.
yeah,
This is very good.
thank you.
So is there a 9P client for Linux?
Yes, 9P is built into the kernel. It's called V9FS. It's a kernel module, and you can mount 9P file systems with this over TCP, IP, and UDP, I think, and also over a file descriptor, which is what I'm using, which is a TTY USB. And then there's also some others that I haven't used, other transport mediums that Linux supports that I haven't used for V9FS.
So you don't actually have to write anything for Linux, it's all ready to go.
Yeah, it's all ready to go on Linux, but if I wanted to mount a 9P file system on another fourth system, like another microcontroller, like another sensor node, that might be interesting, potentially.
Exactly. Which is a very good concept. Literally, you can have like you had that thing where it said 20 kilometers,
Mhm.
like you had your target, but
Yeah.
it doesn't matter what the link is.
Yep. Just defer key and emit.
You can have whatever your source thing is.
Yeah.
Almost like the cloud concept, cloud computing.
Yeah.
That's good. And like I said, you put it in a safe place so that if you
Just back up your sensor nodes. Yeah.
not that we've done that.
Yeah.
Yes.
But V9FS is missing something that is blocking me from doing that. That is sort of a blocking me from completing the deferring of key and emit, so I can do it over a radio link. There's a tauth command in 9P that is completely agnostic to any crypto system, but you can do you can secure your 9P with that, but V9FS doesn't support it apparently. But maybe I need to add the support for that then.
Yes.
Yeah, so we could do that. And then
So does this mean that on your server you're doing the file allocation?
right now I'm just doing like a static file set of files, but that was a problem I was struggling with, was how to allocate, how to have a file system that's simple. For now, I'm just doing something static, as I said, but also a problem for, yeah, maybe region-based memory allocation would be interesting. I think Anton Erdel was working on that in fourth, and that might be something to do, or B trees. But yeah, it's complicated. It's not as simple as I would like it to be, but yeah. 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 But on the other hand, I was thinking, I was reading about the Canon Cat and Jeff Raskin, who created like the fourth computer, the Canon Cat, and he said that an unlimited length name is a file, and the best content of a text file is its own best name. So I guess this is really like a pragmatic compromise with Unix, this 9P file system for fourth systems. Although in a way we are sort of moving away from file systems for the general customer's computer, because your tablet and your phone isn't really file system oriented anymore. I still like files, but seems we're moving away from them for better or worse. But I think it's still a good way to organize things, organize data. But yeah, it's sort of addressing only by searching is interesting as well, I think.
So this comes pretty close, this stage comes pretty close to GitHub, right?
GitHub?
Well, Git.
Yeah.
But basically you keep track of how you're doing that.
Yeah. Yeah. And this is just like you search with the, you press the leap key and then you just type in, I think it'll search for whatever you're looking for. I think that's how it worked. I don't have a Canon Cat. I wish I did, but.
You have never seen.
Yeah. But it's had this, and you just search, instead of searching, you just search for within the entire text, something like that. I think he then went on to do Ubiquity and Firefox a while ago. And then there's something similar to this, like a note-taking app, Notational Velocity, I think it's called, where you just type and then it will create notes that way. You don't organize them into individual notes. You just, with titles, you just start typing. Yeah. All right. Thank you.
So Dennis, would you want a computer? Not have enough computers? I don't know. Do you have enough computers? Are you going to bring your own, or do you want to use mine for your talk, which you're going to present? No. Well, no, I think I'm going to do it online. But they don't need to see my face. Aha. I need a longer extension cord at this time. Yeah.
Do you like your mic back? Yes. Microphone, yeah. Let's not touch the microphone.
Yours.
Thank you.
Oh, yes. And I think I'm live, sort of. And what we're going to do is just share my screens. Screen share. Let's do the entire screen, and it's going to go crazy for a moment. So excuse me.
There's an exhibit at the Hoover Exhibit Pavilion of Doom called Double Exposure, Russia's Secret Police under the Last Tsars. And it looks good, and it runs till March 12th. So you have scant few weeks left to go see it. March is about to start. Hoover Exhibit Pavilion. You know where the tower is?
There we go.
Well, near the tower is a little exhibit space that they have. You can Google it. The last 20 years, and by pavilion, they don't mean like a tent. It's a building.
Okay, I haven't been around here for 20 years, so it's.
Okay, but you can Google it. With your friend. Just the key phrase is Hoover Exhibit Pavilion.
I'm also not, but I remember when they put up the engineering library, they now tore it down. So I've actually.
Okay. This talk, there are no slides. There are no slides. There are some web addresses. Why should there be? This came out of the Hack Summit just happened this last week. And the week before, I saw it was happening, and I saw that they had a hackathon in it.
And so I put onto the SVFIG mailing list, who wants to play? No takers, which is interest. I find interesting to the fourth community. We have been considering fourth as a very efficient way to program. Yet I see very few examples of fourth in programming contests. I don't understand that. I don't understand why we don't try to, well, I sort of do understand it. I've been around this community of lone wolves for many years, and that's what we are. As I said, you've seen 1/4, you've seen 1/4. There are tons of fourth. Nobody, even within our community, there are not many people on any 1/4. We can't even agree on the fourth. So getting us to program together is not something we do a lot. And so that sort of explains why we don't join in on contests, is we don't have a lot of people that get together in teams. We don't scale ourselves up to larger teams. I think the most I've had in one team all doing fourth was around 7 people. I've never seen more than that. I've never been able to manage more than that. It's just the way it is. But this came about, and it was interesting to watch. Definitely it is worth going out to this and at least looking at some of the speakers that they had. Come on. There we go. Actually, no, that wasn't where I wanted to go. That's not going to show me the whole list of speakers. Come on, go back. Let me go back. I think down here, yes. I watched the keynote starting up. The ones I thought were interesting was this guy, Kent Beck, TDD. I love his stuff. He's a very interesting guy. And Joe Spolsky, been following him most of his stuff too. And also watched this lady's talk. She was the CTO in the White House. Very interesting. I don't know. She did talk about the Obamacare disaster. Yes. Yes. That White House. And very interesting. Another thing that they had, and that I tried to sign up for, is, and here's some of the list of programming contests. And I've played around with this guy. It's an interesting programming contest every year. Very interesting to play with. And I think I even did it in 4th. It's the on the International Conference on Functional Programming. They do a programming contest every year. It's a fun toy to play with. Didn't even finish, I don't think, because I was in the middle of a job hunt at the time. It's the only time I have time to do anything like this. And it turned out that the programming contest in this case, you had to sign up ahead of time. And I missed the deadline, and without knowing that I missed the deadline. Where did they talk about that? I can't remember. I can't find that at the moment. They do have a bunch of programming rules. They had a whole bunch of in the hackathon. And Kevin asked the question. Where did Kevin go? Disappeared on me. What is a hackathon? It's a programming contest. You see them all the time. They have them here frequently. In fact, that may be what, there's two groups going on today. One of them may be a hackathon. You get a bunch of people together, and they typically program over the weekend or even overnight. And you don't leave until you're done. It's an interesting way of programming. It's to get to market. It's to get to market. You throw away all the rules. You just get it to market. And one thing I didn't realize on this particular contest was that you had to make a web app. And well, there it knocks us out. Unless I could have gotten Brad to help. He might have been able to get a web page going with Forth. We don't do that much, and it's just part of the mystique of us. So it was just a thought. The other piece that they used here is they used this guy. I've belonged to coding for a while. Coding is an interesting IDE. It's purely on the web, and you just define Ubuntu configurations and you run on the web. And this allowed them to do a coding conference, a hackathon, using a fixed computer. They provided the virtual machine. So they knew exactly what was in it. They knew what you added to it. They knew what it took. Because one of the major rules in a hackathon is you have to write the first line and the last line, all of the code, during the hackathon. You can't bring anything with you. Which is a hard one to enforce, a hard rule to enforce, unless you own the VM. If you own the VM, you're done. Then you can compare it, find out exactly what the people did to it. And I've never done anything with this coding VM, but it's nice. It's a full Linux. Oh, what's it gonna, this thing is saying it's not valid anymore. Oh, there it goes. Okay, so we've got a full Unix. This is just a README. And I think I have set up a Forth in it, GForth. Yeah, so I've got full GForth. It loads almost everything. That was the wrong thing to type, but it works just like anything else, and I don't have to have a computer to do it. Sort of. I still have to have something that runs a browser. But as I said in my thing, there's not much to talk about. There is a way to share it if you want to. Do you want to try the sharing? We got time. We got time. So what we can try to do, and yeah, we're gonna, yes, we're gonna go into a little bit of an infinite loop here. Yeah, let me stop that for a moment. Stop the screen share for a moment while I add, oh, whose name do I've got to add for you, Kevin? You're the prog chair. Do you get that email?
Hang on a second. See if I can remember.
Is coding anything like Docker?
My impression is that it does use containers, which is what Docker is just containers. I think there's a tie-in there, but I don't know what it is. I don't know how they're doing it, but it looks a lot like containers, which is all that Docker is.
Yeah, I also know in the JavaScript world, they're getting to the point where they have development things. It started out that you could put a piece of code and what it looks like on a web page, and now there's all different sorts of people who have loading systems and the rest built in, so that people can basically see other people's code. You don't have to download anything on your personal computer and run it. You basically go to the web page.
Yeah.
It sets up, separates the HTML, the CSS, brings in all the files, runs it on their service, and all you do is click, you get the URL.
Right.
Here's my example. Here's what's screwed up on Stack Overflow. You point to that page.
Right, and that's basically how Amazon Web Service works. Is you've got a container, and they run their container in their virtual machine.
But when you want to talk to other people, like me in the JavaScript world, because you've got all these stupid libraries and all this CSS and all these different things, trying to get somebody, unless you can bring them over to your computer.
It's svfourth@gmail.com.
Okay, we'll try that.
That's the chair. That was the one.
Oh, that was it?
Yes.
Now, how do I get back there? Oh, SVFIG. SV Prog Chair?
Yeah.
That's him?
Should be.
You should have gotten an invite.
I'll let you know.
We haven't tried this yet,
Should
but
go to my Gmail, right?
it should go to Gmail, that Gmail.
In that Gmail now, you can see all of these things that go to this account.
And
New
nothing
York
happened.
Times is pestering me. But other than that, I don't get it now.
You didn't get a
Most people are
mail.
able to read the part where it says, "Do not reply to this email."
Hi. Then let's try just blind then. And what is your normal? Start session.
Yeah, this is svfourth@gmail.com. SVFORTH.
Oh, no, I have to do that up here.
Yeah, that's it. svfourth@gmail.com.
Yeah, it looks like I bet this has got to be somebody that's already on coding.
Oh, sorry. Not gonna happen.
Nothing here. Yeah, okay. That was why we were doing this experiment, to see what the requirements were. We might do that if somebody has interest in signing up to coding. We can do it some other time. Bring your computer. We can do it at any point. because I have no clue what sharing means. There, I can share a session. Any questions? I don't have much else to show.
Context, there's a time limit, there's an objective that you have to meet in the time limit. It would be interesting to see how so many good fourth programmers with their own particular specialties could come together.
Yeah, I've thought so.
And that in itself is kind of interesting because you could actually, if you could look in on that process and follow all of that code, you would get to see a lot of good code written in one place.
And
As a teaching tool, as a way to see how something goes from, and to be able to capture. I'm just thinking, just the fourth guys, not the other team, but the people, to be able to hear and to capture what's being said, right?
Mm-hmm.
And then going along with the code, okay, the communication back and forth at that platform, very interesting.
It would be. I've done, on one job I was doing, I did pair programming in fourth. It was difficult. It was very difficult to do that. And I haven't figured out why that is, other than we are lone wolves. All of us are lone wolves.
Well, wolves can come together when the time is right.
Only if you let, the only way wolves work together good is with an alpha male or female. But you have to have an alpha.
Just bring food.
True, but you have to have an alpha. Well, could be. Could be.
On that note, I've also thought, on that note, of the alpha, Chuck's out here one time a year. I don't know if he's the alpha, but if he's out here.
Chuck doesn't want to be the alpha. It is the problem. He's walked away from our mess. That's why he tried to be on the ANSI committee. He had to walk away. I mean, if you've ever been on a standards committee, you can understand why. He's the initial lone wolf. He wanted one computer for himself. That's all he wanted. And we've all learned from him. And so we don't, I've seen it work that I can get a team working together. Pair programming, in my opinion, didn't work.
How many times did you try?
Once. Well, we tried to make it work. It was about 9 months on this job, and it was on Chuck's chip. We were a group in Colorado trying to do it. And it was just interesting.
I don't think the language matters. I think what matters is learning to speak what's in your mind, what you're thinking as you're doing it, so your partner and you can talk, converse, and keep up. You know, you're not only saying it in code, you're saying it in English as well.
Yeah, and it might work with the right set of people. Finding the right set of people is hard because of the lone wolf mentality. I haven't found that team. Yes.
So I was thinking, like, what if there's a package manager for fourth, not just libraries, but individual fourth words?
We've tried that.
Yeah.
That was Flag.
That was what?
Flag.
Flag?
MPE, over the guys over in UK,
Yeah.
have Flag, which is for not down to the word level,
Yeah.
but a library of fourth.
Yeah.
We also have the scientific community that Skip Carter has set up. That's a very ad hoc bunch of fourth code.
So he's not quite a lone wolf, alpha lone wolf, not a lone person yet. So before you become too much of a lone wolf, it's probably a good time to team things.
Right. It's going to take the next generation.
That's right.
My generation, us old folks, we failed. We didn't make it happen.
Sometimes blazing your own trail and factoring a program to fit your own application can sort of be isolating. If you just diverge too much, if you think too much on your own, it can be very isolating, and I found that myself even.
Oh, it can very much.
Isolated when I just make a decision only on technical merit, not on popularity contest. I think what would be the technically best way to solve this that I can think of, and then it diverges from the so-called network effect chosen solution, and I feel very isolated because of that.
Right, and I think something like this hackathon is a good model. If we can get enough younger people that want to take forth to the next level.
Yeah. I don't think it's going to happen. There was a guy giving a talk in the late 80s here at Stanford. I sat in on the course. Basically, it was examining different languages as you could either have something that's expressive or declarative or a blend of them, right?
Mm-hmm.
Fourth, by its very nature, is very expressive.
Yes.
Write once, read never, right?
Well,
declarative languages have a lot of cruft to help other people do it.
Right.
Whenever I see people's code up on the screen, and people here want to share it. That's the reason we're here, right?
Yes.
What I see, and I've got enough gray hair that I think I qualify for this. I was at a time for 20 years of my life where I wasn't allowed to use more than 6 letters in a variable name. You know, standard Fortran. Right?
Oh, yes, the old ones, yes.
In a big program, that was a big hurt. When you're trying to do scientific stuff, and you literally would have to spend a half a year learning that, well, alpha is this symbol and such is so-and-so.
Yeah.
Today, whenever you do web programming with JavaScript, everybody does it with pair programming. And if you read the code does not have anything with 4 to 6 letters. It has, I'm taking this out to such and such. And so you see people with fourth seem to have this thing of, can I tuck my code into one little block or one little screen? And that's wonderful, but it's not the kind of way that you do modern programming. And so I see that everybody in JavaScript gets together and works nicely. I don't ever see the fourth language as doing this. It's an expressive language. It's not declarative. And as soon as you put enough rules in, it won't be fourth anymore.
People have tried, and it's not fourth anymore.
Exactly.
And yeah, absolutely right.
Doesn't necessarily mean it's bad, though.
No, it's
There are
not.
lots of fourth-like things and derivative things that are, of interest or good or.
It won't be as small as fourth anymore. You start adding all these rules on, and that adds size.
Yeah, but
on the other hand, if you go to a JavaScript hackathon, I don't want to be critical. One of the reasons I hang out here is not because I'm a fourth programmer. There's a lot of genuinely bright people in this room. When I go to hackathons, people who are mediocre in intelligence can contribute.
Correct.
And if you want to grab code, throw it on some stupid little Wi-Fi thing that does not work, and has to get it running, you need one genius. You won't even get 12 people. 100 people, you have no hope.
Correct.
One person.
Correct.
So each language has its niche.
And it promotes being a lone wolf. We are very, very smart in our own ways. There is little overlap with any of us. we can share enough that we can understand each other. But coding, the same? That is, we don't have the habit of doing it with a team. We don't scale ourselves.
To say that someone has a fancy for a certain type of thing, like Brad, he's got
Right. I was going to mention Brad's haikus are the ultimate. They go down to one letter for a word.
so Brad has this particular niche thing about how he sees that, how to get that. So that's his, and in effect, he himself is like an alpha male.
Oh, yes.
For the new ones who come in, want to learn, and they haven't got to become an alpha male yet, they can work with him to work on something they understand that.
Yeah.
They're not limited to that. They may move on, cross-pollinate
Oh,
over to someone, your thing, whatever your specialty.
the people that are doing his haikus have very little recognition that it's actually fourth, and they have no desire. They share among themselves and they compete with each other on how small to make it.
So what I'm saying is, this is the foundation, and all over the world, all these guys are gray hair.
Yeah.
That's the foundation. They're all alpha males because they've all become lone wolves.
Yeah.
Their own particular thing. This team got his thing. That when someone's interested in that, they gravitate to him and they get that.
And then they go off in their own path.
That's right. But it's not a single sliver type of skill set. You want to round off. That's how you get the team. When the team is like for example, military SEALs, we do everything.
And they do it together.
That's right.
They build the team.
Not a one person only does communication. Right. Someone is taking out communication as well. But you have so it's this cross-pollination piece that working on these things. People haven't become complete lone wolf. No one trained more lone wolf just yet. When cross-pollinating, moving around and getting the direct insight on how to do that. And then they're able to bring that together. Going out to a contest would be interesting because
I think so.
Thinking about it, I was thinking, well, what would be happening in the first bout? You've been in these hackathons with two people, they're going at it right away.
Oh, yeah.
They open the box, they're going at it. And I thought, well, what would happen at we're a 14? What would the 14 be?
Same thing,
They wouldn't be
different ways.
I was thinking that they probably wouldn't be on the computer right away.
Oh, most of them would, yes.
You think so?
Twiddling bits. Yeah.
Because that's he would say, or a new person would say, reading everything out on the web.
Maybe.
They
Maybe.
would be thinking maybe to think about right? So isn't that what the books are saying? And what
It is sort of it. There's two schools of thought that you have to program top down. You have to think top down, but code bottom up. And I've programmed that way of stub programming. And it works real nicely in Forth. It's beautiful in Forth. It's why it's fast. We didn't teach that well. We have not taught that. And that's a shame. It's part of what Forth is somewhat lost. As you were saying, we have taken Forth that used to be compile debug or edit debug. There was no compile cycle. We've removed that. We've gotten away from that. And there is a compile cycle in there. With AM Forth, it's a huge compile cycle and then download cycle.
because as new people come in, they're bringing different things. said, oh, it's like a distributed force. And Clark said, oh, yeah. So new concept coming in.
We're starting to see that now. We're getting a lot of you younger folks, and I encourage it. Bring in the ideas. We've got to be better at this than the next guy. We lost to Java 15 years ago when Java had Java Card. Java Card still won. We were on the lost. Java Card won. They're still there 15 years later. We have no place in the smart cards. We've got to have a win. We've got to merge with them somehow, and I don't know how to do it. Internet of Things is huge, and we have a huge place there if we can take it.
Yeah. Feedback control.
Well, I mean, it's like having a fourth thing or MP fourth or something that's obviously compiles across all the different platforms and it unifies those things. So it's easier to code. Right?
Well, we let Fourth Inc. and MPE take over FIG. FIG had all of those models. That was, I don't know if any of these, were you around in the original FIGs?
No.
You,
I was 1 year late.
yeah, I don't think any of us were in that original team. They're all real old now.
I was just late.
Yeah. Well, yeah, we are real old ourselves. Yeah. But we are not the original team. The original team was a bunch of guys, and they made a bunch of fourths. Then we let the corporations have them, and did ANSI. Screwed it up.
I found that Chuck and I graduated from college in 1961.
Okay. I was a decade later.
He was in computers. I was in chemistry for 20 years, and then it was too late.
Yeah. And so hackathons, I think, are neat. I think they're for you guys. I don't even participate much anymore because I can't get a team. There's no team among us. There's no money. Oh, there is no money in doing contests. There's absolutely, but is there any money in anything that's fourth anymore?
I guess you'd have to ask Leon.
Leon's making money.
Leon has been known to make money.
MPE is making money.
He's pointing satellite antennas and somebody's paying him for it.
LMI's not anymore. MMS is not.
Not for many years.
Exactly. It's down to MPE and Fourth Inc.
But
they haven't made any money for a very long time.
Going out and doing jobs, they were selling
Fourth.
MMS fourth.
Right.
And not supporting it with
Yeah.
When you asked him for help, and he would want to call you back, collect.
Yes, because he didn't know how to make money himself. Yeah.
The thing part of this, okay, so you brought up the hackathon. To me, that's sort of like field trip.
Oh, it is.
You learn field trip, and then the things you learn on the field trip, we're able to bring back and then figure out if there's a possibility for business. Right?
That's what most of the hackathons are. Is come up with something that might actually make money.
Right. But to say we don't want to go to the field trip because there's no money in the field trip. We know there's no money in the field trip. It's not about the money in the field trip.
But the VCs are at the hackathon.
Right,
They are watching the hackathons.
right. And they're gonna be interested in a team who come to the hackathon.
Right.
And at the end of the time, have a product that's ready to go. They'd be really interested.
I think it,
But
Dennis, you might watch the hackathon and see if there's anything that we can do. And, just the whole challenge, the programming challenge.
It might be. It might be that. We've done challenges before. We haven't done one in a long time. You did.
The last
You
fourth day,
won.
weren't you there?
Yes. Yes.
Well,
Yeah.
it wasn't much of a challenge. Yeah, we need bigger.
We didn't have prizes. Which is something that the hackathon has. So anyways, thank you for listening. Okay. Thank you, everybody. We'll see you next month. Bye.